Once again, we're starting with a project. I'm gonna open up my terminal. I'm gonna navigate to the folder that I want to keep my files. I have a folder on my desktop called El Captain for this class. Inside of it, we have a ton of folders. I'm gonna add more as the class moves on. I'm gonna run git clone, git clone. Say again? It's okay. It's okay. So I'm going to paste this, and what can I do if I already have this repository? Kung was right. I already have this repository. I cloned it. I was playing around with it yesterday. So after we run git clone and then the git URL of the project that we want to clone, we can simply rename it. We can simply type in another one, monster catch. So I'm going to be cloning these files. Now if I run ls-al, I can see. Exactly. It's what we call an argument, a command line argument. There's a ton of different command line arguments that we haven't explained yet. And you guys, as you guys develop as professional developers, you're going to learn about them. Almost every single tool that you guys use here in the command line will allow you to pass in additional command line arguments. So, a moment ago, we didn't have a folder called monster catch. But now we do. So we need to move into it. Now we've set up our project, or we'll set up one of our tools. We've got our terminal command line here ready. Let's go ahead and set up our new tool. Let's open our code editor and look at the files. So you can see that Charles here left some comments for us. I'm not going to get into too much detail for this. The key skill here, right? Like this is like, it's not all about coding, right? We said that before, and we're saying it right now. I'm saying it right now. A lot of it is about reading someone else's code and just like thinking about their variable names. You're like, what does that mean? And then testing, like, oh, okay, well, I think this is what this means. I think this is what will happen if I change this one variable or I add this one parameter, etc. And that's what we need to, figure out how to do. So we're gonna try to do that. So just a quick overview. We have something called Canvas. Canvas is a special tool of of HTML5. You guys can read more about it right here. There's a lot. There's so much to it. There's so many complicated animations it can do. But we're gonna start very small. We just want to have a person to be able to move up and down and left and right, and things appear on the canvas, and for the for it to be randomly placed, for there to be a score and a timer. So back to the code, right?
And this is an HTML.
So this is HTML right here. Let's go ahead and look what we have. We reveal it in the Finder. We open it. So right now the problem is that the default state, when I move, it goes off the screen, right? And if I move right, it also goes off the canvas. So Charles hasn't done everything yet. He needs us. Okay? This game sucks. How fun is a game that you can't find your hero? Right? We need to find our hero, and the hero needs to do logical things. He cannot just go disappearing into the white. Yeah, and also the monster keeps moving down into the right. So you guys are gonna need to read the code where it says, hey, move the monster. And there's gonna be some type of thing that says that for somehow computes, it makes the monster move down and right. Okay? So instead of doing that, we want to randomly place it. Okay? So I'm gonna start off by doing that. And then you guys can copy. Okay, so let's go ahead and look at our code. We see we have a bunch of JavaScript objects set up. We've got some width right here. If we scroll down, we see a function, load images. This function is a utility function. All it's going to do is set up a background image, which is using a new data type, image. It's gonna attach an event listener, which to its onload property that says, hey, whenever I'm ready to load, whenever I've loaded, set this variable background ready to true. And then obviously the hero, the monster, etc. What I like doing, right, is when we see a function, right, and we open up a new file, let's look at what we call the functions. Let's just follow the function calls for a little while before we start getting into too much detail. So I'll double click this, I'll do Control D. So we can see that the comment says, hey, let's play this game. So the first thing we need to do is make sure we have all our images loaded, all our assets. The next thing we need to do is set up keyboard listeners. So I double click this, do Control D. So now we can see that there are 2 event listeners added. One of them, what does this look like, guys? Yes, this is a function. If we type it in our console, we were even giving it in the description right here, right? So we can fire it. So if we look at this function, we can notice that what's the first argument? It's a string. It says key down. The first argument is a string. The second argument is what? It's a function. And specifically, this is a anonymous function. The function does not have a name. This function is passed to the add event listeners as an argument. The last argument is false. I'm not sure what all these do, okay? But what we can know is that actually I do know what it does, okay? What it's doing is it's saying, hey, I need to pay attention to a key down and a key up. These are 2 very important keys, okay? And then it's just going to map over them, and then it's going to apply them momentarily. So keys down is an object, and we're paying attention to which keys are pressed down on. I'm gonna prove that to you. Okay, watch this. Oops. Oh, damn it. I need it over here. Update. Right here. Right here. So as we're moving our keys, right? As we're pressing keys down, this event listener just pays attention to what keys we're currently pressing. And it's constantly recycling. Well, that actually, the recycling is coming from somewhere else. But this is what we call a render engine. It's a render engine. We're constantly looking at the state of the application and rendering it based on that state. And this is happening very, very quickly. This is how games are built, okay? Your game, just through the magic of computer science, us depending on other people, right? The game is constantly just paying attention to its state, and then if the state is like if someone's standing here, then draw him right there. Someone's standing there, draw them right there. Every single game works this way, okay? So anyway, we added some event listeners. We don't need to know that right now. This is why the code is set up. You guys can research it more for those of you who are really interested, okay? So we're gonna go ahead and remove this console log. The next thing that we see is that we fire our main function. Okay, so what does our main function do? It fires an update function and then a render function. And then here's another setup step for cross-browser compatibility. Once again, you guys can see the comments. Okay, you guys are gonna clone it. You can read the comments and you can do more research if you're interested. But just know that our render function is going to be constantly firing through the life cycle of our game. That's the mental picture that we need to have. Do I have any questions so far? It's constantly firing. Oops. Come on. I gotta close some windows, guys. Okay, so on line 131, what are we doing? We're console logging. What is this? This is a render function. Our render function just constantly firing. I don't know how it's all set up. It just does it for us. Yes? I don't know. Let's test it. Hello world. In React, it is a special function, which you're right. You cannot rename it as anything else. But evidently here we can. Hello world, refresh. It's this function right here. This is the one that's causing it to eventually fire again and again and again, because this is a game setup. Put it that way in the canvas. Okay, so I keep showing you guys. I keep getting off track. I need to update this. My bad. So, all right. So you guys can see when I'm moving once again, the hero just when I go too far to the left, he goes off the screen, right? So now the problem becomes, I don't know where his X and Y are. If you guys look at this code right here on lines 115, this is the setup that allows us to pay attention to when the hero is touching the monster. There's some setup for us. So instead of looking at that, let's just look at where the hero is. Okay, that's what I'm interested in right now. So we're gonna say console log hero X right here, this value. Refresh, and I can. Okay, let me go ahead and delete this other one. So the console log. Okay, so I see that his X, right, is at 256. If I move left, our number is getting smaller. Does that make sense? Let's do it real slowly. I'm moving left, it's getting smaller. Now it's negative. So what do you guys think there's a line right here represents?
0.
Yes, that is 0. That is 0 on what axis? The x-axis. Okay? So, what is the condition here that we're checking for? What do we want to do if the hero goes less than 0?
Reappear.
On the right. We want him to reappear on the right side over here. Okay, so we need to know two things. When is the hero at 0 or lower? And what it is on the right here. What is that on the right? I don't know what that is. Is that 100, 200, is that 400? I don't know. Okay, so let's just test. If hero X is less than or equal to 0, we're just gonna set the variable again. Hero X equals 100. Okay, so you can see what 100 does. So now I'm gonna refresh the page. That's about 100 right there. Yeah. That doesn't seem. So we could obviously hard code this some more and get it really close. But I think a good idea would be to look at our variables. This is something we're constantly going to do. So there's a reason why we have to define our variables before we use them, because they give you an idea of the state of our application. It allows us to think like, oh, okay, so this is, this is our application. So right here, we can just look at the canvas width. So I'm gonna say if the hero's X is less than or equal to 0, we're gonna set the hero X back to the canvas's width. So we refresh, move left, we can now see that he appears on the other side. But what about going from right to left? Okay, come on guys, come on. What am I doing? If the hero's X is yeah. Then what do you want to do with the canvas width? All right. But now we have a little bit of a bug. Now I can't move from right to left. This is because sometimes we need to have something called add padding or buffering. Because for a moment, right, this one right here, it's blocking. So we're going to now add a -5. We're going to do -5. I think this will fix it. To be honest with you, sometimes that's what programming is. It's a little bit of guesswork, I'm telling you, I read this code and I wasn't really sure what it did. I had to experiment with it. This is our job, to experiment with code. Okay, so I think the problem here is the hero's X, as long as it's 5, less than or equal to 5. Fuck, man. Okay, I'm going to cheat. This is going to be the first in class. I forgot how I solved this. And actually, I'm going to do this more in class in the future, guys. I'm going to look at some previous examples because I don't want to waste your time. What? It was -10? Okay, my bad. I had to give it some additional padding. I don't know why this is, why it's this way, but it's blocking it somehow. So now you can see What? Hero X. From right to left works. Left to right doesn't work. X. Less than equal to -10. If hero X is less than or equal to 10. Come on, is this really gonna work? Okay, what the fuck? How are these two different, guys? How's line 116 through 122 different than 125 through? What the fuck? Is that really what it is? Is that really what it is? What's gonna fix this? Save it. I'm not sure. There's a little bit of padding. There's like a section that overlaps where like it's preventing one from firing when it should fire. We're gonna have to experiment with code. I showed you guys the example of one of your previous classmates because I want you guys to know that like he did this in the day. You know, like obviously I think he's a particularly good student, right? But just know that it can be done. You guys can like play around with this and add additional behavior very easily. So right now, right, we can go from left to right, right to left, right? I want you guys to look at the code and think about what we've done in class and be able to apply the same concept up and down, left and right. Okay? Left, I appear right. Right, I appear left. Now let's fix this from up and down, left and right, okay? Now, we also need to pay attention to when I'm touching this hero, or this monster. He's always going from which direction, guys? Right? He's going diagonally to the bottom right. So now we need to find some code that basically controls this. So we're gonna read, We're like, oh, not only is there code, there's a little comment. Someone left a comment for us. Nice. Okay, so we can now determine that we know when the hero is touching the monster. And we can see that this code right here is going to place it again. So let's just hard code 100 to 100, okay? Refresh, touch the monster. Oh, he's always in the same place. Every time I touch him. Okay, let's do 500 by 500. So if I touch him, he disappears somewhere else. Let's do 200. Touch him. He's always at 200 and 200. So now the problem is that we need to know what the confines of our game are, right? How far going X is off screen, how far going Y is going off screen, right? Have we already established what line this is on the Y axis? 0, right? Do you remember when we were doing actually we didn't do that one, my bad. But I'm going to tell you this one is 0. Okay, this is 0 on the Y axis, this is 0 on the X axis. Okay? So now what we're going to do is we need to create a new function which will simply.
So if you ended up giving the whole canvas like a margin, would that mess up all of those points? Like if you try to place the canvas in a different spot in the body of the page, would those numbers get all mixed up?
You know, I do understand what you're saying. No, I already did it last night, so it doesn't have to. But obviously, we're gonna run into bugs, right? Adding margins and stuff. This is bound to happen. I think I did this just this morning, or was it last night? I forgot. Yeah, so this is the one I did. Remember, it's actually moved. The canvas is moved. We can set the parameter, the width and the height of our canvas as well. I have another project. I couldn't find the file. I'm sorry. I have a bunch of projects in my folder on my computer. I couldn't find it, but I have one where the canvas is like entire width and they have a whole bunch of stuff going on, right? So remember.
So that's 0 on the canvas, not 0 on the page.
Exactly. And then the canvas is what? Let's look at our HTML. Let's look to the right. Okay, let's click this. This is one HTML element right here. How many children does it have? Exactly. It's a self-closing HTML element. What is controlling it, guys?
The script.
A script that contains JavaScript. JavaScript is controlling this. Okay. There's no all of these colors here. These colors, the position, all that. There's no Bootstrap doing this. There's no HTML. There's no CSS. This is all done by JavaScript. Okay. Okay. So anyway, what have we established so far? Again, what have we established? We figured out how to go from left to right, right to left. We don't know how up and down, but we can force our hero, our monster, to just randomly move. 200, 200. So now we need to randomly pick a number here in two places, guys. Is there a way to randomly pick a number?
Yes, we just did this today.
Okay. Does anyone remember how to do that? Or can someone tell me every key?
Math.4.
Math dot what?
4.
Okay.
Right on number.
You have to know what max though.
This render.
The truth is, I don't trust any of you guys. I don't trust any of you to write it by memory. Okay. So I'm gonna go ahead and just Google it. Random JS integer between 1 and n. Trying to prove a point, man. All you guys put your heads together, man. I'll give you guys 5 minutes. I'm not 100% sure you guys can do it without looking at an example. Okay? Come on, man. Oops, I need to close this. Sometimes it takes a second. JS random number 1 to 100. Right here. Okay, so what's the width of our canvas, guys? You just look at our code. Let's read our code. And you're right, you looked at a code. Good job, Sean. So we're going to randomly place them. Wait, was that the X? I forgot. Okay, yeah. So randomly between, the X, whenever we touch the hero, we're going to get him between 0 and 512. Does that make sense, everyone? Okay, what about for height? 480, right? So we save it. Are you kidding me? Best time. What is it called again? Monster catch. Okay, so now if I move around, dope. Does anyone have questions on how we did this? He's just
See how he's like popping up kind of halfway on the side there?
Yep.
We could put some like padding by decreasing the number.
Exactly, we could do that. Sometimes it's hard coded, guys. It's okay to hard code sometimes. That's one of the things that took me a while to figure out. That there's nothing that's ever gonna be perfect, man. If you guys show someone like a working example with bugs, no one's gonna be unhappy with you. If they paid you money, right, and they want something built, they have no idea to do it, and then like you ask them for a week and some money, and then you show up a week later, it kind of works. They're like, all right. How much more time do you need? That's what they're gonna tell you. I promise you. There's a whole army of people like that. Okay, so yeah. So here we are. So the next thing we need to do, right, is what? We need to pay attention to how many times a hero has touched it. So we're going to define a new variable, score. We're going to initialize that to 0. And every single time, what happens? We touch the hero. Then, we touch the monster. We're going to kick up this number. Okay? And then we're going to console log it. And I kind of don't like, so this is something that we're going to see a lot. I don't like the way Charles wrote this code. Right here. And I'm going to update his code. He should have given me a variable here. Const hero is touching the monster. That's what I want. That's what a pro developer does. And I'm not saying that Charles is not a pro developer, but I'm trying to say is like you need to constantly be telling your friends what you're doing. Right? And you need to tell them what this means in the UI. right there. That is so much more explicit to me. I don't even want to think about it. All I gotta do is read this one variable and I already know what all this magic is right here on line 136 through 139. Okay? Does that make sense to everyone? So for me, like he has comments here. So like there's a healthy balance here. Ideally speaking, you should not have comments in your code. If you have comments in your code, that means that it's like unclear what it's doing. We could pick better variable names. Okay? And I've had code review where people complain to me about that. I wrote a little comment. I wrote one line. And he's just like, why do you have a comment here? He was like, he took me out. He's like, hey Lloyd, you have a comment in your code. You know? But this is for you guys to read as well. So this is for you guys to read and learn and to, you know, dive into some code and just to play around with it and learn. So now we're gonna save it. We're going to jump back to our browser and test what we've got. Let's refresh. Let's clear our tools. Let's move around. And we can see that we're now getting a console log. Well, where did he go? Where'd he go? He's somewhere here on the border. So we have a bigger bug, to be honest with you. He needs to be actually quite smaller. I would say 510, 505. Fuck it, man. Let's just say 500.
It was 512 when you made it higher.
Oh, really? I made it higher?
I think you made it higher.
I'm an idiot. My bad. What was the original number here? 512 and 480. Okay, my bad. Come on, baby. Okay, so we're touching him. We're touching the monster, and we're winning. Yay! There are a couple other requirements. If the user gets 20, we stop him from playing, etc. And by the end of today's lab, I'm gonna add a couple more features, and I'm gonna show you on the second time around. Okay? So you guys see that what we've done so far. What are the requirements here, guys? Tell me. What are we doing? Someone help me out here. Are we building a little game which pays attention to when the hero moves around? If it goes to off one side of the screen, he starts off to the back. We pay attention to when the hero touches the monster, right? We change the place where the monster is moved onto the screen. We also pay attention to how many times that they touch the monster. We also want to show the user. There's a lot of screen here, okay? Show something interesting. Tell me my score, right? Tell me my score. Remember that there's a lot more we can do here. Quads is dope, man. She balled out. You guys can customize a lot. Play around. Read the documentation for Canvas, okay? See guess how he's changing these numbers right here? You know? We've done something very similar to this yesterday, as a matter of fact. How's he keeping track of the level? You guys should all play around with this on a second, okay? Play around with this for a second. The Froggy. What's that game called? Froggy?
Saving Froggy.
No, but what's the one real game when it first came out? Frogger? Where you jump across the road and don't get hit by a car? Okay, Frogger. Alright, so just so you guys know, this is actually how like life is as a software developer. Typically, you have a morning meeting, you know, and then you spend the whole afternoon working by yourself, and then like trying to focus to get your job done. And every now and then you'll talk to your colleagues and be like, hey, I'm having a problem with this. Can you help me out? But you should be like doing research, right? Right now, we've been given an objective. You've been given some code and told to read the comments and play around with it and read the documentation and implement something else. Okay? So we're gonna get into that habit of that's what we do. You know, we get given a finite set of instructions, and we're given time to research and to experiment, and then we come up with solutions. At the end of the day, that's what we're doing, guys. People have problems; they want solutions. We're gonna give them their solutions. Okay. Do you have any more questions? All right, you guys do it. Come on. We're gonna go to GitHub. We're gonna look for the project, Canvas, starter game. Then we're gonna do fork. We click this button right here. Right here. I can't do this for you on screen. Okay, I can't do physics on the screen because I've already done it. But just know that what we're doing is we're gonna get a copy of this project and we're gonna move it to our own repository, our own account. And now this belongs to us. Okay, so here's my version of it. Okay. So see right here, look, right here, it's my username right here, Canvas Game Starter, but it's forked from Code School Canvas Game Starter. This will become important later when you guys want to become open source developers. You guys will probably never ever fork otherwise unless you're doing an open source project. If you work at a company, you're just gonna clone it because you all want to be updating the same code. You don't want to have 20,000 different versions of your Facebook app, right? So forking is not really that useful for your job. Unless you look at it from the perspective of like if you know how to write to an open source project, you're a pro developer, and then that obviously everything's a balance when I say certain things. Okay, guys, fork Charles's repository. When you fork it, what are you gonna have here? You're gonna have your own GitHub repository. Clone it. Clone your own repository. No problem. Okay, is that clear, everyone? All right.